Hi everyone, welcome to Organic Chemistry, Module 7. So I've set up this module a little bit differently to how it's set up in the syllabus. So rather than doing um, different groups and doing naming, reactions, and properties of each of the groups, I'm going to go through and do all the naming first, then all the reactions, and then everything else. Okay, so it's going to be a bit all over the shop, but I think it definitely is set up better this way. So we'll start with organic molecules. Now, syllabus outcome is investigate the nomenclature of organic chemicals up to C8 using IUPAC conventions, including simple methyl and ethyl branch chains, including alkanes, alkenes, alkynes, and halogenated organic compounds. All the other stuff I'm going to do in a separate video, okay, but we're going to concentrate on those things first. Now, there's lots of basic stuff that we have to get through before we can start doing all this naming. Firstly, what are organic molecules? Well, they're any molecules in a large class of chemical compounds that contain one or more atoms of carbon, are covalently bonded, and also contain hydrogen, oxygen, or nitrogen, also covalently linked. Okay, so they're the basis of it. But it's that the most important is that carbon. Here's some examples. We have propane, we have acetic acid, we also have meth. Okay, so there are three there. You can see all of them have carbon, oxygen, hydrogen, nitrogen. Sorry, all of them have carbon with hydrogen. Some have oxygen, some have nitrogen. Okay, you can see that there's some with single bonds, some with double bonds, all sorts of different things. Okay, so these are examples. There are three ways of drawing organic molecules. Okay, the first we have Kekule structures. They're the ones on the previous page. So there's just carbon, hydrogen, drawing all atoms, all bonds. And it's the one we use that I will be using the most. Okay, but there are some different ones. There are condensed structural formulas that you'll need to be able to read. Now with this one, the bonds are omitted, and we can just draw it like straight into text, just like this. Okay, so for example, butane, which is just C4H10, the structure is written like that. So it's a CH3 with a CH2 with a CH2 with a CH3. Acetic acid, now I'm sure you've asked me many times, why do we write acetic acid as CH3COOH rather than C2H4O2? Well, it's because it is the condensed structural formula. Okay, acetic acid is a CH3 with a CO and an OH on the end. Okay. Ethanol, CH3, CH2, OH. So at one end is a CH2, then there's a one end is a CH3, then a CH2, then an OH. Okay, it gives us that little structure. We also have line formulas. Now these are used predominantly in university, just because it's so much easier to draw, but it requires a bit more thinking. Okay, because carbon atoms are omitted, as well as hydrogen atoms and bonds. So, for example, in that first molecule there, we got three lines. Okay, what that is, it's actually butane. So there's four carbons, one at the end of each carbon-carbon bond, but the carbons themselves aren't drawn in. Also, all of the hydrogens are implied, so they're not actually drawn in. So wherever there's not enough bonds on a carbon, we fill in the rest with hydrogen. So these examples, we have butane, we have acetic acid, and we have, I'm pretty sure that's just meth again. Okay. Now, the names of organic molecules are based on the number of carbons in the parent chain. So that's an important word that we'll have to remember, parent chain, as well as the types of atoms that are bonded to the carbon chain. Now, naming. We always start with the parent chain, which is the longest chain, or the one with the most important other other atoms attached. But we only have to remember up to 8. So if there's one carbon, it's meth, whatever. 2 carbons, it's eth. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. If we were to do simple things would be like methanol, ethanol, propanol, butanol. So they're the first four alcohols. Or we can pick, straight chain hydrocarbons, the alkanes, methane, ethane, propane, butane. Okay, that's how we name them. You might have heard of octane. Octane is 8 carbons long, and it's just a straight chain hydrocarbon. So here's an example. So number of carbons, 1 with the name meth, just 1 carbon. Eth is 2 carbons in a row. Prop is 3. But is 4. Okay, and that's straight chain. 4 in a line, all connected to each other. So that it's carbon bond, carbon bond, carbon bond, carbon for but, for example. Okay. If there was carbons in different areas, then they're not the straight chain. So we're mainly looking at the parent chain, so the single longest chain that's there. And we'll get to more of that shortly. But yeah, make sure you remember those. Meth, eth, prop, but, pent, hex, hept, oct. Now, hydrocarbons. What is a hydrocarbon? It's an organic molecule consisting only of carbon and hydrogen. And the main 3 types of hydrocarbons are alkanes, alkenes, and alkynes. An alkane is an organic molecule consisting of carbon and hydrogen with single covalent bonds between them. They're named by the parent chain followed by ane. So methane, ethane, propane, butane. Pentane, hexane, heptane, octane. So they're the first 4 alkanes. Okay. You can see, I'm sure a lot of those chemicals are actually quite familiar. So methane, produced by cows, very bad greenhouse gas. Propane, we use it in liquefied natural gas. Butane is used in lighters. Octane is used in cars. Okay, so these are all hydrocarbons of the alkane variety. Here's some examples drawn with our Kekulé structures. So methane, it's a carbon with 4 hydrogens around it. Butane, 4 carbons in a straight chain with hydrogens all around. Hexane, 6 carbons in a straight chain with hydrogens all around. Now, alkenes. Alkenes are organic molecules consisting of carbon and hydrogen atoms with at least 1 double carbon-carbon bond. They're named by the parent chain followed by ene. So there is no methene because we need to have at least 2 carbons because we need a double bond between 2 carbons for alkenes. So we start at ethene, we also have propene, butene, pentene, hexene, heptene, octene. Now here's some examples. So remember, carbon has 4 bonds available to it. So in ethene, so ethane would be C2H6, so there'd be 3 hydrogens off each of the carbons. But because we now have a carbon-carbon double bond, we can only get 2 hydrogens off each of the carbons. Okay, so it's C2H4. And we follow that through the rest of it. Having a look at propene, that first carbon has 4 bonds, so 2 of them go to hydrogen, 2 of them go to another carbon. The middle carbon has a double bond to 1 carbon, a single bond to another carbon, which leaves 1 bond free for hydrogen. Okay, so on and so forth. Now, you'll notice there at the end, I've got something called but1ene. Why is it 1? What is it there? Why is it there? Well, it's important to tell where that double bond is. Now, realistically, we can put the bond in 2 different places and still have butene. We can put it at the end or in the middle. And so the number refers to in the chain where the double bond is. So but1ene has the double bond on the first carbon, starting on the first carbon going to the second. But2ene has a double bond starting on the second going to the third. Okay. Now, you might be saying, but Dr. Chaban, what about but3ene, the third carbon going to the fourth carbon? The carbons are always numbered so that the lowest possible number or combination of numbers is given. So with but3ene, it doesn't actually exist because it's just but1ene counting from the opposite direction. So realistically, but3ene does not exist. It's just but1ene drawn differently. Okay, drawn the opposite direction. It still starts at 1. Okay, 1 to 2 is a double bond. Okay. And that's something that you'll have to remember through a lot of this naming stuff, is that we always number the lowest possible number. Okay? Doesn't matter if it's drawn left to right or right to left, it's still the same molecule. Now, alkynes. Alkynes are organic molecules consisting of carbon and hydrogen atoms with at least one triple carbon-carbon bond. And they are named by the parent chain followed by "-ine". Now, again, we need at least 2 carbons for alkynes. Sorry, that should say alkynes at the top. The first one is ethyne. The common name for that is acetylene. So if you ever use an oxyacetylene torch, you're using ethyne. We also have propyne, butene, pentene, hexyne, heptene, octene. So here's some examples. So the first one is ethyne. So carbon-carbon triple bond with hydrogens for filling out the 4 carbon, like the 4 bonds on carbon. Down the bottom we have but2-ine. So again, it's the triple bond is starting on the 2nd carbon, going to the 3rd. Top right corner we have hex3-ine. So the triple bond is starting on the 3rd carbon. And bottom right we have oct3-ine. So again, we have the carbon-carbon triple bond starting on the 3rd carbon. Remember, we always number at the lowest. If it was the other way around, it wouldn't be oct5-ine, it would be oct3-ine, but we number from the opposite direction. Okay? Always the lowest number. So in summary, hydrocarbons are organic molecules consisting of only carbon and hydrogen atoms. Alkanes have only carbon and hydrogen atoms linked by single covalent bonds. And alkenes have at least one double carbon-carbon bond. Okay, that's it for today, and get on to the questions. Thank you.